Okay, so we're finally at the point where we're going to be graphing this entire trinomial ax squared plus bx plus c. So our learning goal. We are going to find the axis of symmetry. Oops, I will. Find the axes of symmetry and the vertices of graphs. And I will graph quadratic functions of the form y equals ax squared plus bx plus c, and then finally I will find minimum and maximum values. And remember, that is really just finding the vertex, so that is just kind of an added little thing in there, but it's definitely not tricky. So there's our learning goal. Okay, so we're just going to start off with some things that are good to know when we have y equals ax squared plus bx plus c. So the first thing is which direction our graph is going to open. Our graph is going to open up when a is greater than 0. So if this is positive, we're going to open up. It's going to open down when a is negative, or when a is less than 0. So that's our first important thing to know. Next, good thing to know. The y-intercept is always c. So 0c is always going to be on your graph. So this right here is your y-intercept. And then when we're finding the x-coordinate of the vertex, so we're going to have to find the vertex, the x-coordinate is this formula, negative b over 2a. So that's something you're just going to have to know. And then, so similarly with that then, the axis of symmetry, remember that goes through the vertex. So the axis of symmetry is x equals negative b over 2a. So when we look at this right here, we can use this information to help us graph it. So we actually are not going to have to make a table of values to graph these functions. So we're going to want to keep all of these things in mind as we go through the rest of this section. With our first example, we want to find the axis of symmetry and vertex of the graph y equals 3x squared plus 12x minus 2. So remember, to find the axis of symmetry, we need to use this, negative b over 2a. So x equals that, that's a line, which is the axis of symmetry, and then our x-coordinate of the vertex is going to be just that negative b over 2a. So this is a, this is b, and that's c. So we will put in negative 12 over 2 times 3, and we get negative 12 over 6, which is negative 2. So the axis of symmetry is x equals negative 2. So that just means we have a line going through negative 2. A vertical line going through negative 2. And then to find the vertex, we know that the x-coordinate is negative 2, but we don't know what the y-coordinate of that vertex is going to be. So if I had, like here's, oops, very sloppy. But what I know right now is that this is my axis of symmetry. So my parabola is going to open up, but I don't know, is it going to open up here or is it going to open up here? I know it's going to be somewhere along this line. That's where the vertex is going to be, but I don't know where. So what I'm going to do is I'm going to take this value for x, and I'm going to substitute it in to my equation to find out what the y value is that corresponds. So I'll do 3 times negative 2 squared plus 12 times negative 2 minus 2. Negative 2 squared is 4, so 3 times 4 plus 12 times negative 2 minus 2. So remember, I know my x-coordinate of the vertex. This is how I find the y-coordinate. So that's 12 plus negative 24 minus 2. 12 and negative 24 make negative 12 minus 2. So my y value is going to be negative 14. So my vertex is going to be at negative 2, negative 14. So that tells me my graph is actually going to be way the heck down here somewhere. But remember, this just had you find them. We don't actually have to graph it. So axis of symmetry, vertex. Okay, now for an on your own, find the axis of symmetry and vertex of y equals 3x squared minus 2x and y equals negative 1/2 x squared plus 7x minus 4. Remember, we're going to use x equals negative b over 2a. That's a, that's b. In this case, c is 0, but we don't need that anyway. So we're going to look at this. We're subtracting 2. Another way to think about that is adding a negative 2. So in this case, b is negative. So negative 2 over 2 times 3. That's using the formula. Negative b over 2a. That's 2 over 6, which is 1/3. So 1/3 is the axis of symmetry, that vertical line that goes through x equals 1/3. And then I'm going to take that 1/3 and substitute it in to find my y-coordinate of the vertex. Minus 2 times 1/3. 1/3 squared is 1/9 minus 2/3. So that's 1/3 minus 2/3. I have a third, I'm taking 2 away, so I have negative 1/3, which means the coordinates of my vertex, so let's write axis of symmetry, and then my vertex will be at 1/3, negative 1/3. I'm going to follow the exact same method over here. So x equals negative b over 2a. In this case, a is negative 1/2, b is 7. So negative 7 over 2 times negative 1/2, which is negative 7 over negative 1. So I get a positive 7. And then, so x equals 7 is my axis of symmetry. And then I just need to substitute in for that x, so negative 1/2 times 7 squared plus 7 times 7 minus 4. Negative 1/2 times 49 plus 49 minus 4. Let's see, half of 50 would be, what's that, 24.5? Negative 24.5 plus 49 minus 4, so that's going to be positive 24.5 minus 4, or 20.5. That's my y-coordinate. So my vertex has the coordinates 7, 20.5. Hopefully I didn't go through that too quickly. Really, the key was just using the formula that I was given. Okay, now that I know how to find the vertex and the axis of symmetry, I can use that information to help me graph any function. So if I have y equals x squared minus 4x plus 1, and I want to graph this, what I'm going to do, that's a is 1, b, and c. First, I'm going to find the axis of symmetry. X equals negative b over 2a. So I get negative 4, because that's a negative 4, over 2 times 1. So positive 4 over 2, x equals 2. That is my axis of symmetry. So if I make my x and y coordinate, or x and y plane, I look back at my original function, my graph is going to open up because a is 1, so it's positive. And my axis of symmetry is x equals 2. So this line right here is my axis of symmetry. I also know my vertex is somewhere on that line, I just don't know where. So I'm going to take this and substitute it in. So 2 squared minus 4 times 2 plus 1. This is going to give me the y coordinate for my vertex. 4 minus 8 plus 1. 4 minus 8 is negative 4 plus 1 gives me negative 3. So my vertex is going to be at the point 2, negative 3. So 2, 1, 2, 3. That's my vertex. I know that that's going to be the minimum of my function because my graph is opening up. It's going to look something like this, which means the vertex is the lowest point on that graph. So from here, my graph is just going to go up. What I am going to do in order to figure out how much it opens up, I need to find another point on this graph. The easiest way to do that is to think about the y-intercept. Remember, the y-intercept is just c. That's my y-intercept right there. So positive 1 means that right there is on my graph. And because I know where my axis of symmetry is, if this point is 2 units over from my axis of symmetry, it needs to have a corresponding point that's 2 units in the other direction. So if 0, 1 is a point, based on my vertex, I know that 4, 1 also has to be a point. So I can use symmetry to make that super easy. And now I know what my graph looks like. And I go up through that point, and life is good. So that should have been pretty easy to graph. So just knowing the vertex, the axis of symmetry, and that y-intercept makes it very easy to graph these. So you may have been nervous about it before we started, but hopefully you're seeing that it's really not a big deal. So when you're doing these, you're also going to be asked to find the domain and the range. So remember, I've said this a million times, but I'll say it again. Domain is everything that your x can be, and your range is everything that can come out for y. When you have a quadratic, really there are no restrictions on your x ever. So x is all real numbers. We can do that double bar R, or say all real numbers. My range is going to be all of the possible outputs, everything for y. So you'll see, in this case, because my graph is opening up, and my vertex is at 2, negative 3, the least value my y can be is negative 3. So my range is y is greater than or equal to negative 3. Okay, so the last thing we're going to look at is finding the minimum or the maximum of a graph. So this is pretty easy. If a is greater than 0, that means my graph opens up. So the vertex is the minimum value. It's the bottom of my parabola. If a is less than 0, then my graph will open like this, and you can see that the vertex is the maximum value. So finding those is really easy. It's just finding the vertex. So if we had a function that looked like this, 3x squared minus 18x minus 6. Does this have a minimum or a maximum? And what is it? So think about what this graph looks like. A is positive, so my graph is going to open up like this. I have no idea where my graph is going to open up like that, but I know that this is the general shape, which means that the vertex is going to be the minimum value. So this graph, minimum, Then, in order to find it, I need to use my axis of symmetry to find the coordinates of my vertex. So this is A, this is B. So I have negative B, so negative 18 over 2 times 3. So that's a positive 18 over 6, and 18 divided by 6 is 3. So my axis of symmetry is 3, which means the x-coordinate of my vertex is 3. So now I need to substitute that into my equation to find what the y value is. So put in 3. So 3 times 9 minus 18 times 3 minus 6, that's 27 minus 54 minus 6, so it's at negative 27 minus 6 is negative 33. So the value of my minimum is negative 33. I really just have to say the y coordinate. The lowest that my y can be is negative 33. From there, I could even then say that my range then is that y has to be greater than or equal to negative 33, because that's my minimum value for y. So really finding minimum maximum isn't anything different than what you did earlier in this section. Okay, finally, our real life applications. So we have this function, negative 16t squared plus 40t plus 6. And that tells you the height in feet of a water balloon, t seconds after it's thrown. So like usual, we're throwing stuff. Use a graphing calculator to find the maximum height of the balloon. So this has a negative a value, which tells you it's going to be an upside down parabola. It's going to look something like that. So your balloon gets thrown, it gets higher and higher, it reaches a certain point and it starts coming down. We want to know what is that highest point. So what I'm going to do is get out my graphing calculator. And I need to do y equals, let's clear these. My function was negative 16t squared. So negative 16, I'm going to use x just because that's the only variable they have for us to use, plus 40x plus 6. So there's my graph. I could just graph it, but when I do that, I see that I can't actually see what's going on at all. So if this is how many seconds have gone by, it's like 1, 2, it looks like it hits the ground between 2 and 3 seconds. And right now my graph only goes up to 10 feet. I'm going to go up to 30 feet and see if that helps. So for my window, my x values represent the time that's gone by. I hope you can see that. It's pretty similar. Maybe. Okay, so there we go. Now you can see it. Okay, my x value. Let's start at negative 1 because that'll just show the side of my graph. And remember, the balloon hits the ground after like 3 seconds, so we only really need to go to 3 seconds. I'll go to 5, and we'll count by ones. Let's leave my y min at negative 10. That doesn't really matter. We said we're going to try to maybe go up to 30 and see if we can see the top. So when I made those adjustments, oh look, my balloon's actually going higher than 30 feet. So let's go to 40 feet for my y max. So that was just changing my window. I pushed the window button. So this is how high the balloon is. You can see the balloon starts above the ground. It goes up, it goes up, it goes up, it comes back down, and then it hits the ground over here. So what I'm going to do to find the maximum, I'm going to push my second button and then calc, because I'm calculating the maximum. So second, calc, and you'll notice that maximum is number 4 on the list. So you can either just push 4 or you can go down and push enter. And then it says left bound, which means you want to put the cursor by using the arrows to the left of the maximum. So over here somewhere. And then it says right bound, so I'm going to go to the other side of the maximum. And you notice when you do that, it has those little arrows. So it's going to find the maximum value in between those 2 arrows. Sometimes you'll have a graph that has more than one bump in it, and you might want to calculate the tops of the different bumps. So this is just telling the calculator where to be looking for a maximum, and then it has you guess. I don't even know why it bothers with that, but anyway, push enter, and I see that at 1.25 seconds we have a maximum of y equals 31. So the water balloon is 31 feet above the ground after 1.25 seconds. So that's how I use my calculator to find maximums. And obviously, if this graph were facing the other direction, I would do the exact same thing, but just using minimum instead of maximum. So that is how you're going to use your calculator. So I'd say 31 feet. Your homework for tonight, let's see, is going to be on page 429. And you are going to do numbers 1, 2, 6, 9, 13, 16, 19, 21, 24, 27 through 29, 33 through 37, and 38 through 41. So a good chunk of problems. Now, I showed you how to do it on your calculator, but you do need to know how to do it without the calculator. So don't just use your calculator for everything. That is not going to be helpful for you. Make sure you know how to do this stuff without a calculator. Of course, you can always use it to check, though. So hopefully I didn't just talk too fast. I feel like I'm out of breath. I was flying through that. But if you have questions, make sure you let us know. Good luck.